Hello everyone, welcome back to our channel. Today we are going to break down a very famous string problem, that is valid anagram. You all can go through the problem statement on LeetCode itself. So let's read the problem statement first. So we have been given the two strings S and T. We need to check if T is an anagram of S. Okay. So first of all, what we need to know about what is anagram. So anagram means that both string must contain the same characters, but their order can be different. Okay. So for example, if we see here, it is given input string is listen. So in listen we are having LISTEN. Okay. And we are also have given a string T is equals to silent. So the word silent will contain all those letters which was present in listen. So we can say that listen and silent are two anagrams and we will return them as true. Okay. Similarly in example 2 we can see string S is equals to hello and T is equals to word, but we can clearly see they are not matching, the characters are not matching with each other. So we will not consider it and we will return false. Okay. So what I was trying to tell was quite simple. Like we have to return true if the two strings are anagram of each other. Like means that if both the string must contain the same characters. Okay. So let's think, like if the length of S and T are not equal, so we can immediately return false, right? Because in this, it's a compulsion that the length of both the strings should be same. Okay. So this is the very important case here, which we need to take care. Okay. Then let's move towards the brute force approach. What we can do, basically how we can think of it. It's quite simple question, right? Basically how we can do is using two unordered maps we can take for string S and string T. We can take the two unordered maps and one for S and T. Then we can simply count the frequency of each characters in both the strings. Okay. And after that, after counting the frequency, we can compare both the maps. Basically what we are comparing, basically if they are equal we will return true, otherwise we will return false. So before going to the code, we will try run the example here. Like input is listen, S is equals to listen and T is equals to silent. So character L, so count in S will increment and count in T will also increment. Similarly, we will increment as soon as we get I in S and in T. Similar case with the all the letters here. And at last, if we found that maps are equal, we will simply return true. It is as that simple. Okay. So let's go through the code for the brute force. That is first condition, like if string dot size s dot size is not equals to t dot size, we will not be solving further, we will straight away return false. Okay. After that we are taking two unordered maps, one for string s, one for counting the frequency of string t. Similarly we will increment both the maps, and if we found the frequency of both the maps are equal, so we will it's bool function, so it's automatically it will return true or false. So that was the brute force solution basically. But what we can see is the brute force approach, what is lacking here. Basically we are taking two unordered maps which will take O of n each time. Okay. And comparing these maps will take O of k, where k is the number of unique characters. So the total complexity will be O of n. Although this is better, we can say that not a bad solution, but space here we can see that space is O of k because we store frequency counts in two separate maps. The only problem with this approach is basically it uses the extra space for two maps, which we can optimize. And if we think of very naive approach to solve this anagram problem, so we can simply sort two strings, but that will be completely naive solution. By sorting, we means like we are taking O of n log n time complexity. That is worthless here to discuss, but just for the knowledge purpose I shared with you all. So this solution is quite good, but the space we need to optimize it here. Okay, that will be, now we will think of optimal approach, and how we will do that basically by using a single unordered map. Okay, so how we will do, like we will use one or single ordered unordered map to store the character frequencies, and we will increase the count for string s of I, and we will decrease the count for t of I. And if all the map values become 0, we will return true, and otherwise we will return false. Okay, so we can see the dry run I have done for you all, like same string s and t, and if the character l is there, l is also there in the t, so +1 -1 will become 0, +1 -1 will become 0. In s also +1 -1 will become 0. Similarly, we are doing that way, and if we see that all values are 0, we will straight away return true, and that is the case where we can say that anagram confirmed because all the values are 0. Let's go through the code how we are doing this. It's quite simple and very much similar to the brute force that I told you. So basically same condition here. If the string size of both the strings are unequal, then false. We are initiating the unordered map. We are doing iterating the strings, and we are increasing the string of s of I count and decreasing the count for string t. And if all the values in map are 0, it's an anagram. We are taking a for loop, and we are checking if it.second not equals to 0, we are returning false, else we are returning true. So this is the required solution, and it's quite optimal because building and modifying the frequency will take O of n, and checking the values will all take O of k. So the total complexity will be O of n, and the space complexity will be like constant, only one map, so better than the brute force. This was the right approach, and in the optimal one, we are able to reduce the memory usage as well. So I hope you guys understood the solution. If you have any doubts or questions in your mind, please put up in the comment section. I will be more happy to answer. Thank you.